Okay, and a good morning to everyone. Fleetwood Mac, finish off with that, and going your own way. And just a reminder of finals coming up. Today's our last tutorial. It's our last broadcast of the semester. And for those who have been watching on the 3C Media Solutions and the Palomar Network, we will be finishing up today. And then what I would like to do today is a review for the final. I asked the folks who are here to bring in the tests that we've taken, test 1, 2, and 3. We're going to spend some time looking at the problems there. And I thought we'd start out by looking at each of the tests and ask the question, what kinds of problems would you select if you were trying to write an exam that's comprehensive, covering first, second, third test, and new material? So we'll start with exam 1. Now, does everybody have a copy of the test in exam 1? Okay, Michael, you don't? Okay, here's a copy of the exam. Okay.
Can I get one too, please?
Well, if you're borrowing one, just use that right now, because I want one I can reference up here. Does everybody else have one? You don't have a copy of the test itself. Okay, I'll let you walk forward and pick it up. That's the last one I think I can give out. These are the questions from the exam. And the question, again, in terms of what we're doing, let me sort of get a perspective on what a pre-algebra is supposed to be. The pre-algebra is supposed to be well, I'll rephrase that. It starts out with an assumption here that you've had the content in Math 10. So to some extent, we have some review of that content. In another way, I'm very concerned that we not focus too much on Math 10, but think more in terms of what the algebra involves. So if we start with the first test and we think of things that we didn't do in a Math 10, they had to do with operations, order of operations. It has to do with having expressions with letters of the alphabet in it, what we think of as an algebra problem. And in a way, I guess dealing with negative numbers. So that would be, we dealt with negative exponents, if you remember. We graphed with negative numbers on the number line. And so that isn't a totally new idea. But there were 20 questions in this. And what I have in mind for the final is at least 30 questions. So if I do it from that standpoint, 10 questions from the new material at most. And probably at most 7 questions from each of the previous tests. So that would be a third of the questions. So if we look at test 1, and we just take a look at the kinds of things that we were doing, and I haven't written the final yet, so this is an opportunity for both of us to look at what's been done. This evaluation of an expression for different values of x and y became an important idea. The idea, I give you an expression, you substitute into that expression and find its value. Now, as we come off there for a moment, that's not too different from what we were doing in looking at an equation of a line. Okay? So if I go to the board and I look at what should be coming, a familiar friend to you, 3x plus 4y, and I had it equal to 12, I think I had a negative 4y. But if I just ask you to look at the left side and substitute values of x and y, you're evaluating the expression. Now, it so happens that if I choose carefully, I can get 12 out of that by letting x be 0 and y equal 3. But if you look at the problem that I have, again, on the document cam, going back to there, look at that denominator, because I ask you in that denominator, what value of y made that 0? So if I look at the expression, and let's leave it up there for a moment, Ernie, what occurred to me as I was looking at some of the problems, how much what we're doing in this last week relates to what we had done before. Because this question asks, what would make that 0? That was the question in the test. What value of y would make the denominator 0? We don't want a denominator to be 0. But in essence, you were either thinking in terms of this, and therefore y equals negative 2/5, or you could have just looked up here and said, if I had negative 2/5, that would be 2 minus 2, and I would be at 0, and that was the answer. You did not do that well on that first exam. That last part of that first question did not go well. But the point I'm trying to make is that you are, in this process, evaluating expressions. And so if I ask you for the expression 3x plus 4y, and if I didn't put the 12 there and just ask you to give me the value of the expression if x was 0 and y was 3, problem from the first test. Things build on each other. Now, we had a particular requirement here. We had another question where we said 3x plus 4y had to equal, make that 4 a little more legible, had to equal 7. Now, that was a much easier one in the sense when x was 1, y was 1. We had 3x plus 4y equaling 7. Do you see the similarity between the problems? So what we were asked to do, first problem in the test, going back some of the first material, evaluate an expression. Now, coming back. The next one, which was involving a polynomial. This happened to be a trinomial. And you were simply to rearrange it in descending order. So you had 2x squared plus 5x minus 3. The name of the polynomial, we called it a trinomial. It was second degree. And my point in that is I go back up here to this expression. Again, tying the end with the beginning. This is an expression in two variables on the left side. Now, it happens to be an equation. But the expression on the left side is in two variables, and we consider it a first-degree expression because the exponents understood, the unseen ones, are there, hence first degree. Now, because that particular equation, not an expression, that equation has a graph that's a line, we refer to it as a linear equation. Coming back to what I had on the document cam, I mentioned to you that we can set y equal to expressions, and if I look at y equals x squared, that's a very simple version. On the right side is a second degree monomial. Now, comparing that to what I would have had, let me come back to the document cam for a moment. Thank you, Ernie. 2x squared, if I rearrange that in descending order, and then I set y equal to that, we are going to get in both of those graphs a parabola, the parabolic arc. Now, the parabola has this basic look to it, and if you think of a suspension bridge like the San Francisco Golden Gate, this arc we get here is a parabolic arc. It's that equation, y equals x squared. Now, this is also a parabola. And what you do in a beginning algebra and intermediate algebra, you spend a lot of time graphing these. Now, because you get what we call a conic section, an expression, coming back to what we have under the document cam, we refer to that as a quadratic expression, meaning it's to the second degree. Now, those two problems were very much related to what we've been doing. It becomes part of the vocabulary. And as we go down all the way in that first page of that test, here's the 9th problem, in which you have x plus negative 13 equals 25, or x minus 13 equals 25. You are solving an equation. Now, what I'm trying to make sure that you remember, in the same way that I can take this expression up here and ask, when is 2 plus 5y equal to 0? Solve for y. Come back to the document cam. This problem down here at x minus 13 is equal to 25 is fundamentally the same kind of problem. Now, the difference is I do not have a coefficient written in front of the x. It's understood to be 1. So when I add 13 to both sides and I get x equals 38, all I did was move a term from the left side to the right side. How do you move terms? You either add or subtract. Two different things, terms and factors. I didn't like this factor, so I divided by it. You divide to get rid of factors. You either add or subtract to get rid of terms. Now, what we're doing right here isn't any different fundamentally than coming back up to this equation and saying, let's let x be 0. Now, 4y equals 12. Y is 12 over 4. I have been asking you to do that, and 3 days ago when we started doing that, you died. You had trouble just putting 0 here and saying 4y equals 12 and saying, well, y is 12 over 4. That didn't go well. We hadn't done it in quite a while, but that's first test. Okay, coming back, center. I'm going to go to the second page of that test just for a moment and note that most of what else is on that involves working with negative numbers. So things such as the addition of 3 negative values. This is the 11th problem. At this point, I hope that's not causing the difficulty it may have caused right at the beginning. Or the idea of making a distinction between the absolute value and parentheses. Keep in mind that this is like -1 times a -5. This is the negative or the additive inverse of -5. However you think of it, that's 0. The absolute value of -5 is a positive 5, hence the answer here is -5. Down here with a bunch of negatives in front. Think of those as negative 1s. So we have 1, 2, 3, 4, 5 negative 1s multiplied together. That's negative at the end, hence -3. But no matter how many negatives I have inside this absolute value sign, you're going to get a positive 3. Those should be, I'm hoping at this point, pretty much no-brainers. Simplifying in terms of order of operations. This is problem number 16. 3 to the square root of 25 minus 20 divided by 4 times 3 plus 7. What order of operations do you follow? Well, square roots first, the radical, but then multiplications and divisions in order given. So this was a 15. I did that first. Then I divided the 4 into 20 to get 5, and then multiplied by 3 to get 15. So the 15 minus 15 goes to 0. Your answer is 7. Now the square roots, the only thing that's interesting here, and I'll bring this up to the extent this is bugging my stats students after 2 years of algebra, they have trouble remembering that the square root of a product is the product of the square roots. So you can rewrite that as the radical over 225, the radical over 400. That's 15 times 20, 300, you're done. The rest of the material there in that page, as we come off of it, is basically arithmetic. I want to look at the extra credit problem because I feel rather passionate about this one. Be ready for it. I haven't written the test. But there were 11 properties. If you remember, Emily didn't have her question, but there are 11. It was a community property that was involved at the time. But there are 11 properties of the real number system, using them in terms of A, B, and C. I see that as being on the final. I'll just tell you that up front right now. Haven't made a decision what else is on the final, but the properties of the real number system will be there. There are 11 of them. So as we come off there, remember we have 2 for closure. We have 2 for commutativity. Otherwise, we have multiplication and addition. So let's have that and be done with it. So there are 5 properties. They double. So you have closure, commutativity, associativity, identity, inverse, and then you have the distributive property, which covers both addition and multiplication simultaneously. Using letters A, B, and C, know it. I think you'll see it on the final, unless I have some second thoughts, but at the moment I'm feeling rather solid about that. Now the rest of that test, it's not too difficult in terms of the things we've talked about, but let's look at what we have more or less highlighted. I highlighted the first problem. Okay, let me slide that back up. This is on test 1. Okay, come back there, Ernie. I was just going to slide up. I highlighted this problem. I highlighted this problem. We came down and we talked about, as we come off there for a moment, solving a very simple equation, solve and check. This was the equation we looked at. And then, beyond that, I talked about order of operations. There's another one here that's rather interesting. Come off there from it. This was on a quiz, and you died on the quiz. Strong justification for putting it on the test. That is number 5. Remember, you had to go through and do braces of parentheses, radicals, parentheses, then divide at the end. I like that problem still. Okay, so as we come off there, what I'm now going to do is simply highlight some problems we've been talking about. So I liked number 1. I liked number 5. I liked number 2. I liked number 9. And then in the next page, the simplification with radicals, I like that. And we talked about the difference in absolute value in parentheses. So the ones I've circled so far are 1, 2, 5, 9, 12, 13, 16. And I guess one of these that gave us some trouble. Remember the parallelogram that we had in the quiz, and then we did it in the test? And again, it didn't go well in either case. Seems like a strong candidate. So coming off there. Okay, get a little better sense of what to look at in test 1. Good. Now going to test 2. Okay, who needs test 2? Everybody have a copy of test 2? Okay. What'd you do? Well, we'll try again. One more shot at it. There we go. Pardon? Not another one of test 1. I gave those out before we started, and you'll have to sort of copy for each other at this point. Test 2. Can't pass up a parabola or parallelogram again. And I ask you in this one, give me the expression for the area. Didn't go real well, but nonetheless, I thought it was an important problem. Now, there was another one related to it. This was the perimeter of this figure. A triangle, an isosceles triangle. And so you just added the 3 sides, 2y minus 1 plus 2y minus 1 plus y. I hope that seems a lot easier now than it did then. Okay? So that was number either 12 or 13, one of those two. But here's a problem that would be a big one for me. Here's an expression, 6y to the 4th plus 12y to the 3rd minus 18y to the 2nd, and I would want you to factor. Factor that expression. Okay? And again, the question is, what do you do when you look for the factors of that expression? So let's bring it back up on the screen. What are you looking for? Okay, the lowest exponent on the variable that's in every term. So this is going to have a y squared you're going to pull out. What do you also look for? The highest common factor, called the GCF, greatest common factor. And the 6 will go into 12 and into 18, so this would be a 6y squared. And then you have to put in parentheses what would be left. So you're dividing 6y squared into each of these 3 terms. Now another approach here is to write the 6, the 12, and the 18 as a product of primes. And do it in that fashion. Now notice by doing number 11, in essence, I'm doing exactly what I asked you to do in number 10, which is to divide 3x squared into each of those two terms of the binomial in parentheses. Now when I say divide, you put 3x squared under the 36x to the fifth. You put 3x squared under the negative 21x to the fourth and reduce. Now that comes back to something we just talked about as I come back to the board. And if I had something like, let's see what we have here, 4y minus 3x is equal to, let's say, the 7. And I ask you to divide both sides by 4, and this is where you got trapped if you weren't careful. Because if you put the line here in a 4, you crossed out the 4s and forgot to do it with the 3. Sandra, remember that? So we said instead, do this if you're going to divide everything by 4, and that saves the trap. Back to the document camp. Same argument we made there for the problems at the top of the page. Exactly the same argument. Okay, coming off there. 15 and 16 and 17 and 18 are a conglomerate. I'll just put those all up on the screen at the same time. I wouldn't give all of those, but notice every single one of them is solved. Now this reflected different sections in the book. But what do you want to do in every one of these problems to solve for x? Give me the protocol, if you will, the analysis that you're going to follow. What procedure? Okay, Michael, coming off there now. Okay, stop right there. Michael said you want x by itself. Ideally, on the left side, you'd like x to have a coefficient that's positive, ideally. So you could put x on the right side. So how do you get to that looking at each one of these? Now, what I'm going to do as we come back, I'm going to look at number 15 briefly. Yes, combine like terms. But remember that's a negative 1x, the unseen 1. So that's 5x minus 1x, which is a 4x minus 12. First step. Then I want to add 12 to both sides to get it out of this side. So remember, you move terms by adding or subtracting. I don't want the 3x here, so I'll subtract 3x from both sides. Now look at the contrast to the next problem. You can't go there until you use what property first? The distributive property. What do you have to be careful about here with that minus sign? It is negative 3x plus 3. Negative 4x plus 8. And missing that minus sign cost you points. Well, why is that different, these first two now, as we come down to this one at 9x minus 15 equals 7x plus 3? The difference here between the top one and this one, up here you ended up with 1x at the end. So you didn't have to do anything else. Here you get 2x is equal to 18, and you had to divide by 2, so that made it a more difficult problem. And then this was, okay, now that you have learned how to do those first three, can you make a mess of it and still work with this one? And the gimmick here was this minus sign with nothing in front of the parentheses. What is the understood coefficient of, or at least in front of that product? 1. So that's negative 5x plus 4. Now, I'm not going to give you, out of that test, 4 different problems that are that similar. But 2 would not be bad. So I'm just going to put a note here for me, 2 of those. And you need to practice doing them. Now, the danger here is listening to what I'm doing and say, yeah, I can do that. Yeah, sure you can, if there's no pressure, if there's no stress, and I ask you 5 minutes from now. But what happens if you have these problems with everything else in the test? You are stressed. You're feeling somewhat anxious. If you haven't practiced them, you may not remember. Do what you think you can do by redoing the problems. Okay, then there were word problems. There will be word problems on the test. This first one was translate to an equation. And in the process, you had some troubles with that. We had to learn what some of the words meant. The difference of, for example, the difference of 5 times x and 11. To say the difference of, you keep them in the order they are given. The sum of 13 and 3 times x. I'm hoping as you look at that now, that the sum of 13 and 3 times x, 13 plus 3x, is equal to, or is the same as, 5x minus 11. Done. Now, coming off there, that didn't go well on a quiz, didn't go particularly well on the test, but I'm just going to circle it. I'm going to come off, that was the second page. I have them reversed, unfortunately. But let's see what we have. Again, I'm going to look at a group here, 4, 5, and 6. Okay? 4, 5, and 6. Now, number 4 and number 5. Can you tell me something about what's different about those two? I could use FOIL for both, but I really have to do it in one of them, and the other one I don't. Which one don't I need to use FOIL on, besides the first? Okay, it is the 6th one down here, because this is a conjugate. Yes, this is a minus b times a plus b. So you just square the first, square the last, put a minus sign between, 49x squared minus 25, done. Here, FOIL is about the best way. First, then outers, inners, and last. Then combine what's left. This is the one that you choke on if you aren't careful. What's missing that you must write in or you're going to get burned? The 1 on the 2. So that's negative 2 to the first. Think of that as parentheses with the 5 outside. That's going to become negative 32. Y to the 15. That should be easy at this point. I don't know if it is. So that was numbers 4, 5, and 6. So let's come off there for a moment. I'm just going to circle 5 and 6, put 1 and a question mark on 4. Number 3, that minus sign. I mean, there are a lot of ways of hitting that problem. We just saw one with a minus sign in front of it. This is 2 trinomials. You're subtracting them. Now, just a comment here in passing. The simplest way, come back to that if you could for a moment, Ernie. The simplest way is to put a minus in front of the 7, a plus in front of the x, and a plus in front of the 5. This switches each sign. And you put a minus 1 out in front. Now, I mentioned to you at the time that in algebra you will actually put this trinomial below this trinomial and put a minus sign out in front and then change each of the signs and add. So if you think of this minus becoming plus, the additive inverse of that mess, it's another approach to aligning one trinomial below the other and subtracting. Now, that is done in long division in beginning algebra, and that's why you should be able to handle that subtraction. The question, of course, what is the critical nature of that problem in the broader scope of things? I think I can handle that perhaps with a minus sign in another problem, but I'm just going to put a question mark for myself there. This one is a restatement of an earlier problem we looked at with a trinomial. As we go back to the document cam, it's just a mess. You had to do what first? You had to simplify. And interestingly, as we bring that across, this caused more troubles than I thought it would. I had this as a pretty easy problem. Shouldn't be too much trouble. You have a 2x cubed and a 3x cubed. That gave you 5x cubed. You had 5x squared and minus 7x squared, so that's a minus 2x squared. Then you had an 11 minus 7, and you should get 4, and I was amazed at the number of errors. Now, what we'll assume is that everybody that's making those errors is no longer here. Therefore, you aren't inclined to make those same errors. I'm hoping that's the case. Let's see what else we had here. Way down at the bottom, and I don't know to what extent I want to come back to this, but I want you to be aware of it. The last problem I have listed here, 750 is a product of primes using exponents. Now, the reason I bring that up that is a problem that Sarah asks in her algebra classes. When I teach algebra, I expect students to do that, and if they can't do it, they can't do fractions. They can't do the work that goes on with algebra. I'd say if I had to ask one question of a group of 40 students coming into a Math 70 class, if they couldn't answer it correctly, I'd not let them take the course. This would be it. Coming back to it one more time. If you cannot write 750 as a product of primes using exponents, you should not be in a Math 70. End of story. Acid test. Well, in the same way, the GCF, coming back to the problem just above that, greatest common factor of 18x cubed, 24x squared minus 30, and 30x to the fifth. This, Kim, comes back to your question. You look for what? The lowest exponent on the x, it's x squared, and then you look for the greatest common factor of 18, 24, and 30, and what is it? 3 will do it, but 6 will do it. Will anything bigger than 6 do it? The answer is no, because this is 6 times 5 here, and 5 is not a factor there. So be cautious. Any further questions on those problems? Okay. That was test 2. And I may have to go to a different stack here for the copy I have of test 3. Now I'm trying to give you a sense of where we've been, what we've been doing, and what's important. And the idea of trying to come up with roughly 7 questions from the earlier material. There's test 3. No, it isn't. That's for a different class. There's test 3. Okay. I've spent the last several hours this morning. Started about 5 o'clock trying to get things organized and don't feel like I've done it yet, but working at it. Okay. Number 3 I have in the center of the page, a division. Okay, those are 2 rational expressions, meaning fractional expressions. They have different exponents. Here's a product, here's a division. Now the only difference is you invert this one and multiply, correct? So if I ask this one, you better know how to do this one. So all I would need to do is pick one of the 2 and I would have the other one. Notice I managed to include a minus sign with both of them to make things more interesting to you. And if I look at the first one in that, then this is sort of a no-brainer, because if I ask the third one, you're doing what I did in the first and the second one. So I can get with one, I can get 3 problems on a final. Now up here, you had a choice. What's really critical in this problem I'm pointing to? What exponent's missing? The 1 and the y. So if you're going to write this so you have a positive exponent, you'll have a y squared in the denominator, an x cubed in the denominator. It will be a minus sign, and then what is the greatest common factor of 20 and 45? Do you agree with the 5? So you would have a negative 9 over 4, x to the third, y to the second. Okay. Coming off there, this was the chapter on fractions, right? So we had to have fractions in abundance. Now, we had things like minus 5x equaled 12, or we had, say, 4x equals 28. But here you have a fraction with a negative sign. I'm finding that I've really gravitated to negative signs. But I had a negative 5/8. Now, I remember Sandra making a preference. She preferred to divide both sides by negative 5/8. And somebody else said, no, they wanted to multiply by the reciprocal of negative 5/8, which is negative 8 over 5. Your choice. But that problem, you've got to be able to handle. Now, that fundamentally, and again the question, I'm going to make a note for myself down to number 6, because look at 6. It's forcing you into the same thing, but what do you have to do before you get there? You have to get rid of this 3/4 on this side, correct? So you had to add negative 3/4 to both sides, and then multiply both sides by 3, or divide both sides by 1/3, to get y by itself. Okay, now, coming to the board, Ernie. If I look at this expression here, that's not all that different, except we have a second variable. I say get y by itself, or get x by itself. In this case, I wanted y by itself, so when I did that, I divided everything by 4 first, and then add 3/4 x to both sides, and I get this. That's not all that different from the process we did as we go back to the problem that we see. The difference is I'm not seeing the x on the 3/4. Put an x with the 3/4 and say solve for y, and it's fundamentally the same problem. It's just you can't combine 3/4 x and the 5/8. By the way, if you wanted to get rid of the denominators now, that we can play that game fair, what would you multiply both sides by? I want to get rid of the denominators. What can I multiply by? Haven't heard the right answer yet. I'm still waiting. I don't want to see that 3. I don't want to see that 4. I don't want to see that 8. What? No, I can't. Sandra, say what you were going to say. You're right. 24 will do it. Because what is the LCD of 4, 3, and 8? 24. 2 to the third, 2 to the second, 3 to the first. So it's 2 to the third, 3 to the first, 24, and it will do it. That did not go well. Circle it. Okay. Now I'm going to come down to number 8, and this is where we played the game of if you can do it with fractions, you can do it with decimals. Okay? Now this was simply an expression with a bunch of decimals in it. Those were all supposed to be x's. And this isn't particularly difficult here, but I'm going to contrast that now to a problem on the board where we had something like this, 1.2x plus let's see, what do I want here? 0.6y is equal to 7.2. And then you were to graph it. What did we do with this problem? We multiplied by 10 to get rid of the decimal point. Now, if you come down to the problem that's on the document, Cam, could I multiply everything by 10 there? And the answer, that's a rhetorical question. I don't even want to hear you give me an answer. The answer to it is no, because it's not an equation. It's an expression. Coming off there for a moment, Ernie. You cannot multiply an expression by a number to get rid of decimals or denominators. It's only when it is an equation that you can play that game. But a reminder here, multiplying by 10 moves the decimal over, and this became trivial. Why? I just wanted to move the decimal point one place over, 10 to the first power. Why is this trivial now as a two-intercept problem for graphing? What did I rigged the devil out of it. Okay, I got nice integers, more than that. What's the 72? It's a multiple of both 12 and 6. In fact, 6 times 12 is 72. Okay, so if x is 0, y is 12. If y is 0, x is 6. In the story, two ordered pairs, pot them, join them, line's done. And we aren't going to do the third ordered pair. Okay? Just so we don't get ourselves in trouble with our maybe less than precise ordinate system I'm asking you to draw. And again, so you understand, if I give you graph paper, it doesn't accomplish the same thing. Drawing those coordinate systems, when you've drawn 100 of them, you've learned something about coordinate systems. And my experience, again, in things like a stat course, if you can't do a coordinate system when you walk in the door, you should walk back out the door and take 2 more courses and try coming back. Okay? And I've got too many students who can't simply draw x and y axis and label it in less than 3 minutes. I've had in stat sometimes 20 minutes to reteach that. Not good. Back center. Pardon? I don't know what they were doing, but I think they forgot it, whatever they were doing. Yes, question. Yes, if it were just a 7, it would have become a 70. Very good question. Now, I'm been frustrated with your ability to remember the volume of a cylinder. Okay, back to the document camp. There is a cylinder. Parallelograms and cylinders, you better know how to do them. Okay, and while we're doing the diagrams, coming off there for a moment, similar triangles. I like this one. Okay, similar triangles. What do we need for similarity? What is the argument here? That they're similar. What is true about those two right triangles? When you say everything the same, you have to be careful because clearly the sides aren't the same. The same angles. 90 degree, 90 degree. And whatever this is, it is the same as this one down here. And whatever this little angle is up here, it's an acute angle, but they are equal. If the three angles are the same, we say the triangles are similar. Then, corresponding sides, like this leg and that leg, are in the same ratio as this leg is to this leg. That is, I'll just slide up, you get two fractions equal called a proportion. So from these two triangles, you can get a proportion like I have up here and solve that proportion by cross multiplication. You will see proportions on the final.
So the proportion...
So x, okay, coming back. X is to 12 as 2.5 is to 5. X over 12 as 2.5 over 5. Or x is to 12 as 1 is to 2. So what does x have to be? Okay, look at the diagram with me. If this is a 13 here, and this is a 6.5 here, you divide it by 2, correct? If this is a 5 here, you divide it by 2 to get this. So if this is 12, you divide by 2 and get 6. Done. Yeah. But that's what you're getting when, okay, come to the board. This one's still causing trouble. As I go to the board in that, we said x is to 12 as 2.5 is to 5. That is the proportion. Reduce this. So x is to 12 as 1 is to 2. Now you have a choice here. You can say 2x equals 12, cross product, and therefore x is 6. Or you can say I had to multiply 2 by 6 to get x, so I have to multiply this by 6 to get here. I had to multiply 2 by 6 to get 12. I have to multiply 2 times... Oh, it didn't say that well. 2 times 6, I'll rewrite it. I'm not saying it well. That's what I'm trying to say. 6 times 2 is 12, so 6 times 1 is 6. X is 6. Got it? Back to the diagram. The current confusion in that problem suggests what? You might want to look at it. I can't pass this up just down at the bottom. This is a 12 down here at the bottom. But there's your parallelogram again 3 times. I've had that on 3 tests. Just got to believe that in the final, well, trapezoid in this case, sorry. Trapezoid, 2 parallelograms and a trapezoid. My error. It is a trapezoid. It's a lampshade. Back to the diagram. Okay, so the 12 is down here, and there's a formula for the area of a trapezoid, which is, okay, you're going to add the 2 bases, divide by 2, and multiply by the height. But notice, in 19, there's another translation. Okay? You have translate to an equation and solve. And this has the smaller angle of a right triangle is 1/2 the measure of the other complementary angle. And of course, if it was a right triangle and you had 2 angles were complementary, that meant they added to 90 degrees. So that was supposed to be a little bit easier than you made it. But there's going to be a word problem from the third exam. Now, this is something that is classical in terms of Math 20. Dimensional analysis. Just want to remind you of that. And I had, in this case, 2.5 hours to seconds, but I'll do something with dimensional analysis on the final, I think. And I don't know to what extent I want to do it's some mixed feelings about this problem where you had convert from 80 degrees Fahrenheit to degrees Celsius, and you had to remember the formula for Celsius and Fahrenheit. I don't know how strongly I feel about that, so my ambivalence there, so we come off of it. Doesn't give you much to go on, but let's see how many problems I've circled. Let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 that I've circled, and just a comment down here just to note how repetitious things get in that last problem on the page. 2.5x plus 3, 2.5x minus 3. That's your conjugate again, right? So 2.5 squared is 6.25, so 6.25x squared minus 9. The numbers I have circled are 3, 4, 6, 11, 13, 14, 15, 18, 19, and 20. 11, 13, 14, 18, 19, and 20. And that doesn't mean I won't change my mind. Instead of doing number 3, do number 2, which was a product. But if you can do the quotient, you should be able to do the product. Now, the intent I'm trying to convey here is to get an overview of what we've done and know what to prepare for. I don't want you to be focusing on the wrong thing. So I'm hoping I'm giving you some strong guidance here. Be able to do these problems. Now, what about the new material? And what we're going to do, by the way, for those watching, we are going into a second hour. We'll take a short break. And then we go into a second hour, and what I see is redoing some problems. And just see if we can make it work. And see if we can cover what should be possible, see if you have questions and build on that. If you reach a point where it's just counterproductive, then we'll adjourn for the day. But I think it'll help if we do some of that. Now, new material we haven't tested on. The things we've been doing. Percents with proportions. Graphing lines. Big emphasis on graphing lines, and then we had simple interest. E to the x, y to the x. And we tried to redo the simple interest, and I had a problem. And I'll tell you right now, the problem I gave you, I had given the hour before to the Math 10 group. 3 parts. They had about the same amount of time you did, but it was just the same problem that we'd done in Math 10 this semester. I brought it over pretty much intact, gave it to you right after I gave it to them. It's still a difficult area. We may need to be doing some of those as we look at our review in the next hour. I feel pretty good, and I don't know how good I should be feeling. I feel pretty good about the way we're graphing lines, and I don't know if that's shared by you. I've got, let's see, 2, 4, 6, 7. I've got 1/3 of the class left here today. So for those who have been watching and wanting to know how things have gone, I'm not delighted by any means. We've lost a major portion. We've lost about 2/3 of the class. For the third that's left here, I'm hoping that you're feeling pretty darn good about graphing lines. I don't feel equally as good about simple interest, and I feel pretty good about percents, doing it as proportions, and the similar triangles was a proportional argument also. Now that's the material that we've had since the last test. So let me pull this up, stack this over here, and bring up the text. And what I'd like to do is look at the content we've had in these last few sections just to make sure that we're in agreement as to what you're supposed to be able to do. So our last test was on ratios and proportions and what it meant in Chapter 7. As we look at that, that was dimensional analysis and proportions. We converted using proportions and the dimensional analysis. So coming off there, the two chapters that remained, one seemed to last forever, 8-6. We had it open on the computer for day after day after day. I skipped 8-5 pretty much. So these problems up here, this was just the Math 10 content on percents in 8-1, 8-2, and 8-3. The new material was in 8-4 with proportions. But we do need to do something with percents on the final. So as you're looking through there, you're going to get something out of the first three sections, most likely a word problem translating into a proportion, or 8-2 translating into a problem with percents. I don't see redoing 8-1. But something out of 8-2 and 8-3 and 8-6. So 8-2, 8-3, 8-4, and 8-6. There we go. So I'm looking at up here, 8-2, 8-3, then 8-4. So a couple problems in that group and definitely something down here in 8-6. So if I had just those three sections, there's 3 or 4 problems from there. Okay, as we come off that, then we went to the rectangular coordinate system and the idea of graphing linear equations and points, lines, and angles. And most of this up here was vocabulary, right? And we talked about the rectangular coordinate system. This is where we talked about angles being related angles. We talked about acute angles, obtuse angles, straight angles, right angles. And then we talked about the rectangular coordinate system and graphing, and 9-3 is the big one. So 9-3 of the lines we graphed, as I look at the board now, Ernie, and I go back behind me, certainly something like this one, where I'd ask you to graph. Bring that up a little bit. And then if I look at another problem in this form, that is, give you something in this form and something in this form. Now keep in mind that there's no need to go to this form if you can find two intercepts up here or find points very quickly. But if I give you a problem like this, what am I expecting you to do? You have the slope given to you, 3/4, and just get 1 point and then get your second point by going over 4 up 3. But again, looking at this, 2 or 3, I'd say minimally 3 problems out of Chapter 9, minimally 3 problems, I'd say probably 4 in each, because you have to be able to graph this line, and you must be able to graph this line. What do you know about those quickly? X equals 5 is what? The vertical line. And y equals -2 is the horizontal. This goes through the vertical axis at -2. This goes through the horizontal axis at 5. But a problem, 2 parts. Doing that, a problem like this, a problem that's going to be basically 2 intercept, but I'm not forcing you which way you go, and then something maybe with identifying the, trying to think now of acute angles, obtuse angles, things. Let me go back to that as I come center. I'm not communicating that very well, so let me go to where that is located as we finish up here, this part. In Chapter 9, it's about the second section, and I'll just show you a diagram that illustrates the ideas. Things like this, where you have 2 parallel lines, and we said that the alternate interior angles are equal. So 4 and 5 would be equal angles, so if you know the measure of one, you know the other. 5 and 6 are supplementary angles. They must total 180. Then as I come off there for a moment, Ernie, and come down to vertical angles, So two lines intersecting, these are central angles actually, that first, these two I'm showing are supplementary, so I could find one of them easily, and once I know it, I know the vertical angle on the other side. Okay. And then we had the sum of the angles in a triangle, 180 degrees. I can do something with that to get a problem where maybe you tell me the measurement of angles just knowing those relationships. So as I'm looking at it, 8 problems maximum from chapters 8 and 9. So if I did 8 from there and did 7 from each of the first 3 tests, we're at 29 problems. It looks like 30 is a good number to shoot for. That gives you a pretty good idea of where we're headed. And that was the intent for this hour. Okay, I'm down to, at least for 3C Media Solutions and the Palomar group, this is our so long for the semester. And just a reminder that this course has been coming to you from Modesto Junior College. I'm Dr. Curl. This has been a Math 20. We've enjoyed being with you this semester. We want to thank Brian for his help down at Palomar making this happen. And we've enjoyed having the opportunity. And Ernie's been doing most of the camera work this semester, so he's behind the cameras back there. And Ernie, your selection from Fleetwood Mac.